Cheap doesn't always mean poorly built. Sometimes it means brilliantly engineered. While the big brands chased horsepower and luxury, a few tractors were designed with a different goal: do more with less. Lower cost, simple parts. Smart design choices that made them easy to repair, hard to break, and shockingly efficient. Farmers bought them because they were affordable, but they kept them because they were genius. Today, we're counting down the 10 cheap tractors that were actually engineering masterpieces, machines that proved intelligence beats price tags. Stay with us, because some of the smartest tractors ever built were also the cheapest. Number 10. Yanmar YM Series. At first glance, the Yanmar YM series doesn't look like an engineering masterpiece. These tractors are small, lightweight, and visually simple, almost underwhelming compared to the massive Western machines of their era. But that simplicity is exactly where their brilliance lies. Yanmar engineers weren't trying to impress with size or power. They were solving a much harder problem: how to build a tractor that could work reliably for small farmers with limited money, limited tools, and often limited fuel quality. The heart of the YM series was Yanmar's compact diesel engine, which became legendary for its efficiency and longevity. These engines were designed to run at low RPMs with high torque, meaning less internal stress, less heat, and far longer service life. Fuel injection systems were mechanical, not delicate, allowing the engine to tolerate dirty diesel and inconsistent maintenance, real-world conditions that many manufacturers ignored. This is why many Yanmar engines are still running today after 30 or even 40 years with minimal rebuilding. The drivetrain was another example of smart, cost-focused engineering. Instead of complex transmissions, Yanmar used robust gear-driven systems with thick gears and conservative tolerances. These gearboxes weren't smooth or fast, but they were nearly impossible to destroy. Farmers could overload them, misuse them, or skip maintenance, and the tractor would still keep going. That level of tolerance is not accidental. It's intentional engineering aimed at survival rather than refinement. Chassis design also reflected deep understanding of farm reality. The tractors were light enough to avoid soil compaction, but balanced well enough to pull implements efficiently. Hydraulics were basic but reliable, with fewer seals and fewer failure points than many larger tractors. Even the placement of components mattered. Filters, pumps, and service points were positioned so owners could maintain the tractor without professional workshops. What truly makes the Yanmar YM series an engineering masterpiece is not what it has, but what it avoids. No unnecessary complexity, no fragile systems, no features that raise cost without improving reliability. These tractors proved that intelligent downsizing, when done correctly, doesn't reduce capability, it multiplies it. That's why Yanmar compact tractors quietly reshaped small-scale farming across Asia, Europe, and eventually the world. Number 9. Kubota B series. The Kubota B series occupies a special place in tractor history because it broke a long-standing assumption that affordable tractors must feel crude. Kubota proved the opposite. The B series tractors were reasonably priced, yet they were engineered with a level of refinement, balance, and durability that many larger tractors failed to achieve. This wasn't accidental. It was the result of obsessive attention to detail by Kubota's engineering teams. At the core of the B series was Kubota's small displacement diesel engine, designed for smooth operation, low vibration, and long service intervals. These engines weren't powerful on paper, but they delivered torque exactly where farmers needed it at low speeds, under load. Kubota focused heavily on internal balance, cooling efficiency, and fuel economy, which meant the engines could run all day without overheating or excessive wear. For farmers, that translated directly into lower fuel bills and longer engine life. The transmission and final drive systems were equally impressive. Kubota used thick cast housings, oversized bearings, and conservative gear ratios. This meant the drivetrain could handle far more abuse than its size suggested. Unlike many cheap tractors that sacrificed strength to reduce cost, Kubota cut costs through precision manufacturing and smart design, not weaker components. That's why broken B-series gearboxes are surprisingly rare. Another hallmark of the B-series was operator-focused engineering. Controls were logically laid out, clutches were light, and visibility was excellent. These may sound like comfort features, but they directly affect productivity and fatigue. especially for farmers who spend long hours in the seat. Kubota understood that a tractor that's easy to operate gets used more effectively, which is a form of engineering efficiency often overlooked. Hydraulics and PTO systems were simple yet exceptionally reliable. Kubota avoided unnecessary complexity, using proven designs with minimal failure points. Parts commonality across models further reduced ownership cost, making repairs cheaper and faster. This is why B-series tractors spread globally and developed cult-like loyalty. The Kubota B series didn't just succeed because it was cheap. It succeeded because it felt thoughtfully engineered in every area that mattered. That balance, affordable, durable, refined, is what elevates it from a budget tractor to an engineering masterpiece. Number 8. Belarus MTZ tractors. Belarus tractors, particularly the MTZ50 and related models, are often described as crude, rough, or outdated. But that description misses the point entirely. These tractors were engineered under conditions where reliability mattered more than efficiency, comfort, or appearance. In vast rural regions with poor infrastructure, harsh climates, and minimal access to spare parts, Belarus engineers had one mission: build a tractor that could never be truly disabled. Everything about the MTZ design reflects this philosophy. The engines were large displacement, slow-revving diesels with simple fuel systems and massive internal components. These engines could tolerate dirty fuel, infrequent oil changes, and continuous heavy loads. They weren't efficient, but they were unkillable. Thick cylinder walls, conservative compression ratios, and generous clearances ensured survival under abuse. The mechanical systems were intentionally exposed and straightforward. Linkages, pumps, and controls were easy to see, diagnose, and repair. No hidden systems, no precision electronics. If something failed, a farmer could often fix it with basic tools, welding, or locally fabricated parts. That level of repairability is not a design flaw. It is engineering optimized for reality. Transmission and drivetrain components were oversized relative to engine output, meaning they rarely failed even under severe overloading. Axles and frames were heavy, giving the tractor enormous traction and durability. Yes, this made the tractor heavier and slower, but it also made it dependable in mud, snow, and poor soil where lighter tractors struggled. What makes Belarus tractors engineering masterpieces is their extreme clarity of purpose. They were never meant to be elegant. They were meant to work anywhere, forever, under any conditions, and they succeeded. Even today, many MTZ tractors remain in service decades after production, outliving newer machines with far more advanced technology. In the harshest environments, simplicity isn't backward, it's brilliant. Number 7. Zetor tractors. Zetor tractors represent one of the most underrated engineering success stories in agricultural history. Built in Czechoslovakia, Zetor machines were designed with a rare balance of cost efficiency, durability, and manufacturability. These tractors weren't flashy, but they were exceptionally well thought out, especially for farmers who needed reliability without premium pricing. Zetor engineers focused heavily on standardization and modularity. Engines, gearboxes, and hydraulic components were designed to be shared across multiple models, reducing production costs and simplifying part supply. This approach allowed Zetor to sell tractors at lower prices while maintaining high mechanical integrity. Farmers benefited from easier repairs and abundant spare parts, an often overlooked form of engineering excellence. The engines themselves were conservative in design, prioritizing torque and longevity over horsepower numbers. Thick castings, robust crankshafts, and simple fuel systems allowed Zetor engines to run reliably for decades. These tractors could handle prolonged heavy loads without overheating, a common failure point in cheaper machines. Transmissions were equally robust. Zetor gearboxes used straightforward layouts with heavy gears and minimal complexity. Shifting wasn't refined, but the gears rarely failed. Axles and frames were designed for real agricultural abuse, plowing, hauling, and operating implements far heavier than the tractor's size suggested. Zetor also paid attention to balance and weight distribution, ensuring good traction without excessive ballast. Hydraulics were simple but effective, capable of running common implements without drama. The tractors were easy to service, easy to understand, and forgiving of operator mistakes. What elevates Zetor tractors to engineering masterpiece status is their ability to deliver long-term reliability at a low cost without relying on over-engineering or excessive material use. They represent intelligent, purpose-driven design, proof that good engineering doesn't need luxury budgets to succeed. Number 6. International Harvester Farmall Cub. The International Harvester Farmall Cub is one of the most misunderstood tractors ever built. Many people dismiss it as a garden tractor or a beginner's machine, but that view completely ignores the engineering intelligence behind it. The Cub wasn't designed to compete with big row crop tractors. It was engineered to solve a very specific problem: how to give small farms, truck farmers, and diversified operations access to reliable mechanization at the lowest possible cost. Everything about the Farmall Cub was optimized for efficiency, simplicity, and control, rather than brute force. Its small 4-cylinder gasoline engine produced modest horsepower, but it delivered torque exactly where needed. The engine ran at low stress levels, which dramatically extended service life. Thousands of Cubs ran for decades with nothing more than basic maintenance, a testament to conservative engineering choices. One of the Cub's most brilliant design elements was its offset engine and operator position. This wasn't done for style. It allowed the operator to see directly down the row, giving unmatched visibility for cultivating and planting. That visibility reduced crop damage, increased precision, and made the tractor far more effective than larger machines in specialty farming. This was engineering aimed at productivity, not specifications. The drivetrain was simple and incredibly durable. No unnecessary complexity, no fragile systems. The transmission, differential, and final drives were designed to handle continuous low-speed work without overheating or excessive wear. Maintenance points were easily accessible, allowing farmers to service the tractor themselves. Another overlooked engineering success was implement integration. The Cub wasn't just a tractor, it was a platform. Cultivators, plows, mowers, and specialty tools were designed specifically for it, creating a tightly integrated system. That integration reduced cost, improved performance, and made the tractor more versatile than its size suggested. The Farmall Cub proved that intelligent layout, visibility, and reliability could outperform raw power. It was cheap, easy to own, and remarkably effective, and that combination makes it a true engineering masterpiece. Number 5. Ford 8N. The Ford 8N didn't just succeed because it was affordable. It succeeded because it applied good engineering at massive scale. Ford took proven ideas, simplified them, and produced them efficiently enough that millions of farmers could finally afford a capable tractor. This combination of design intelligence and manufacturing discipline turned the 8N into one of the most influential machines in agricultural history. From an engineering standpoint, the 8N was about balance. The 4-cylinder engine was neither powerful nor weak. It was tuned for durability, steady torque, and ease of repair. The ignition, fuel, and cooling systems were intentionally simple, allowing local mechanics and even farmers themselves to handle maintenance. This drastically reduced lifetime ownership costs. The transmission and drivetrain were robust and forgiving. Ford engineers knew that tractors would be overloaded, abused, and poorly maintained, so they designed components with wide safety margins. Gears were thick, bearings were oversized, and housings were strong. This overbuilt approach made the tractor extremely tolerant of real-world farming conditions. The real engineering breakthrough, however, was the 3-point hitch system. While the concept existed earlier, the Ford 8N refined it into a practical, user-friendly design that worked reliably across countless implements. This transformed tractors from simple pulling machines into integrated farming tools. Implements became safer, more efficient, and easier to control, fundamentally changing farm operations. What makes the Ford 8N an engineering masterpiece is not innovation alone, but execution. Every system worked together smoothly. Nothing was overcomplicated, and nothing was underbuilt. The tractor was cheap to buy, cheap to fix, and capable enough to replace animal power on small and medium farms worldwide. Even today, the sheer number of surviving 8Ns proves the success of its engineering. It wasn't flashy, but it was brilliant. Number 4. Massey Ferguson MF35, MF135. The Massey Ferguson MF35 and MF135 represent a turning point where tractors became truly universal tools. These machines were engineered not for one type of farm, but for nearly every type of farm. That versatility was not accidental. It was engineered into the tractor from the ground up. The engines used in these models were deliberately understressed. Whether gasoline or diesel, they were built for long service life rather than peak output. Conservative tuning, strong internal components, and efficient cooling systems meant these engines could run day after day without complaint. This approach dramatically reduced breakdowns and rebuild frequency. The drivetrain was equally thoughtful. Transmissions were simple, but extremely durable, capable of handling everything from light cultivation to heavy draft work. Clutch systems were strong and forgiving, allowing operators with varying skill levels to work efficiently. Axles and final drives were built to last, not to impress. Hydraulics were where Massey Ferguson truly excelled. The company refined hydraulic control systems to deliver smooth, predictable implement movement. This improved work quality and reduced operator fatigue. Farmers could switch between tasks without needing specialized machines, which saved money and increased productivity. Serviceability was another core engineering priority. Filters, belts, and service points were accessible, and parts were standardized across models. This made repairs affordable and fast, even in remote areas. That's why MF135 tractors became global workhorses, found everywhere from Europe to Africa to Asia. The MF35 and MF135 weren't cheap because they were basic. They were cheap because they were smart. Every component served a purpose, and nothing was wasted. That efficiency of design is what makes them engineering masterpieces. Number 3. Ferguson TE20. Little Grey Fergie. The Ferguson TE20, famously known as the Little Grey Fergie, deserves its place near the top of this list because it didn't just improve tractor engineering, it changed it forever. This was a cheap tractor that introduced ideas so powerful they became industry standards worldwide. The TI-20's most revolutionary feature was its integrated hydraulic 3-point hitch. This wasn't just a new attachment method. It completely transformed how tractors interacted with implements. Instead of dragging tools behind them, tractors became active partners in the work. The system automatically transferred implement weight to the rear wheels, improving traction and reducing wheel slip. This meant smaller tractors could do the work of much larger ones. From an engineering standpoint, this was genius. Ferguson solved multiple problems, traction, control, safety, with one integrated system that reduced complexity, lowered cost, and increased effectiveness. The hydraulic system was mechanical and reliable, avoiding fragile components and allowing easy maintenance. The engine and drivetrain were intentionally modest, but extremely durable. The tractor didn't rely on horsepower, it relied on efficiency. Lower weight meant less soil compaction, lower fuel use, and easier transport. Yet thanks to the hitch system, performance in the field was exceptional. The TE20 was also designed to be affordable to manufacture and repair. Parts were simple, layouts were logical, and farmers quickly learned how to service the machines themselves. This dramatically extended service life and reduced operating costs. Calling the Ferguson TE20 an engineering masterpiece is not exaggeration, it is recognition. Few machines in history have done so much with so little. It wasn't just cheap, it was revolutionary. Number 2. Fordson Major. The Fordson Major represents one of the clearest examples of engineering designed for reality rather than theory. This was not a tractor built to impress engineers in laboratories or win comfort awards. It was built for farmers who needed a machine that would start every morning, pull all day, and survive years of abuse with minimal attention. And that clarity of purpose is exactly why the Fordson Major became an engineering masterpiece, despite being relatively cheap to buy and operate. At the heart of the Major was a large, slow-revving engine designed for torque and endurance, not speed. Fordson engineers intentionally avoided pushing the engine to its limits. Instead, they built it heavy and understressed, allowing it to operate for long hours without overheating or suffering internal wear. Thick castings, large bearings, and simple fuel systems meant the engine could tolerate poor fuel, inconsistent servicing, and constant heavy loads. This wasn't accidental, it was deliberate over-engineering in the areas that mattered most. The drivetrain followed the same philosophy. Gearboxes, clutches, and final drives were designed with enormous safety margins. These components could handle loads far beyond what the tractor was rated for. Farmers regularly overloaded Fordson Majors with oversized plows, heavy trailers, and stationary equipment, yet failures remained surprisingly rare. The tractor didn't rely on complex load management systems or electronics. It relied on strength, simplicity, and mechanical honesty. Maintenance was another area where the Fordson Major quietly excelled. Everything was accessible. Grease points, filters, belts, and adjustments could be handled with basic tools. Repairs didn't require specialized training, and parts could be reused, repaired, or locally fabricated. That dramatically reduced lifetime ownership costs, especially in rural regions where dealer support was limited. The Major's weight and balance also played a critical role. Its mass translated into traction and stability, allowing it to pull effectively without elaborate ballast systems. While this made the tractor slower and less refined, it made it dependable in poor soil, mud, and tough working conditions. The Fordson Major proves a powerful truth about engineering. Complexity is not strength. Thoughtful simplicity applied correctly creates machines that outlast trends, technologies, and even entire generations of newer equipment. Number 1. DT75 and Soviet workhorse tractors. At the very top of this list stands the DT75 and similar Soviet-era workhorse tractors, machines that redefine what it means to be an engineering masterpiece. These tractors were never designed to be efficient, comfortable, or modern. They were designed to survive, and that singular focus produced some of the most brutally effective agricultural machines ever built. The DT75 was engineered for environments where failure was not an option. Remote regions, extreme temperatures, poor fuel quality, limited spare parts, minimal technical support. Under these conditions, sophisticated engineering becomes a liability. Soviet designers understood this and stripped the tractor down to its most essential functions. What remained was pure mechanical resilience. The engine was large, slow revving, and astonishingly tolerant of abuse. It could run on low-quality fuel, survive extended oil change intervals, and operate continuously under heavy load. Internal components were oversized, clearances were generous, and cooling systems were built to handle extreme heat and cold. Efficiency was sacrificed for reliability, a conscious and intelligent engineering trade-off. The drivetrain and transmission were equally uncompromising. Gears were massive, housings were thick, axles and tracks were designed to absorb shock, resist twisting forces, and continue operating even when partially worn. Failures were rare, and when they did occur, repairs could be done with basic tools and minimal expertise. Welding, machining, and part substitution were not just possible, they were expected. Perhaps the most brilliant aspect of the DT75's engineering was maintainability. Every component was accessible, systems were modular, parts were standardized across decades of production. Entire tractors could be rebuilt repeatedly, extending service life far beyond what most Western machines could achieve. Many DT75 units have been working continuously for 40 to 50 years, a lifespan modern tractors rarely approach. The DT75 was cheap, not because it was poorly made, but because it was intelligently simplified. Nothing unnecessary, nothing fragile, nothing decorative. Every kilogram of steel served a purpose. This is engineering stripped to its essence, machines built not to impress, but to endure. And that is why the DT75 and its Soviet counterparts stand as the ultimate example of cheap tractors that were truly engineering masterpieces. Those tractors weren't budget machines. They were lessons in smart engineering. By focusing on simplicity, balance, and real-world use, they delivered performance far beyond their price and earned respect that expensive machines couldn't buy. Which affordable tractor do you think was secretly brilliant? Drop your answer in the comments. I read every one. If you love underrated machines, clever engineering, and real farming value, hit like, subscribe, and stick around. Until next time, work smarter, not pricier, and keep the iron moving.